Hey, students. So today we're going to talk about the last bit of our um, three-dimensional shapes with surface area and volume. We're going to go over spheres and hemispheres. So if you think about it, guys, spheres, the Earth, balls, baseballs, basketballs, volleyballs, all that good stuff. Since today is May the 4th, well, the Death Star, so it's sphere-like, except for a little spot there. Um, you know, we'll be fun with it here today. Yeah, there we go. A little Death Star. There we go. There's our Death Star. So all those are spheres, and a hemisphere would be like half of a sphere. So if you cut this thing in half. So a sphere, very much like a circle. If you remember the definition of circle, it said all points equal distance from one central point on a plane. A sphere is all points equal distance from a point called the center. I'm sorry that came out. That should say center. And this is in a three-dimensional space. So we go all the way around. So everywhere you see this R, no matter where along the sphere, the edge of the sphere is R. All right. Now, the two formulas that go with this are your volume and surface area. So the volume of a sphere is 4/3 pi r cubed. Right? 4/3 pi r cubed. Since we're in three dimensions, just like we did volume, it's whatever the unit's cubed. So r cubed. Surface area is 4 pi r squared. It should be very familiar. It looks like four circles because, again, pi r squared right there is the area of a circle. So 4 pi r squared. So it would take four circles to cover this sphere. And so that's what would happen. So given that, right, I do ask a question here. Find the volume of the surface area of the sphere with a radius of 8 inches. So we're going to do the volume and surface area real simply down here. We're just going to use our formula. So we're going to start with volume. Volume equals 4/3 pi times 8 cubed. Now, that's not necessarily the easiest number to multiply, but again, we can use a calculator. So if we talk about 8 cubed, right, we're talking 8 times 8 is 64, and then times that again by 8, and you end up with 512. Now we're looking at this, and I'm moving the 512 over and putting the pi on the end just because I want to leave it in exact values, which pi is according. Now, the thing is, 3 does not go into 512. As much as we know it goes into 12, it just does not. So it's not the easiest number. So what we're going to do is, all we're going to do is multiply that 512 by 4, which gives us 2,048. All over 3 times pi, and we're talking about inches cubed. So there's my volume, and that's the exact value volume. If you want the decimal equivalent, you can get that. And then for surface area, very simply, we're just going to go 4 times pi times 8 squared. So basically, that's just 4 times 64, which is going to give us 256. And it's 256 pi, and in this case, inches squared. So we're just using the formulas real quickly and simply. Sorry about the sniffles. Hemisphere is what it is. It is half a sphere. You live in the northern hemisphere. You live in the western hemisphere if we're talking about the Earth. The Earth is relatively a perfect sphere. Not quite. It is a little more oblong, and that's due to gravity and all that stuff. But it is a sphere that we live in for the most part. So the formulas are going to change just slightly. Volume is pretty simple. Volume is basically, guys, if the volume of a regular sphere was 4/3 pi r cubed, if you take half of that, it's going to be 2/3 pi r cubed. So that's the volume of a hemisphere. Now, surface area is slightly different, because what you have to realize that surface area of a regular sphere was 4 pi r squared. Now, you're saying to yourself, well, we're taking a hemisphere, so we have half of that. Yes, that would cover the dome. I'm going to write dome here. The dome part of it. That is 2 pi r squared, right? But what you see is when we cut the hemisphere in half, we have the circle on the bottom. So you have to think about this as we have the dome and we have a circle, which is another pi r squared. So if we really want to think about it, that is going to be 2 pi r squared for the dome plus another pi r squared. So in all reality, our surface area of a hemisphere is 3 pi r squared. And that is if it is freestanding, as in there's nothing else attached to it. If there's something else attached to it, then that's different because the surface area is not touching. The volume won't change on that. All right, so let's answer the question at the bottom. What would be the surface area and volume of a hemisphere with a radius of 4 centimeters? So my volume is going to be 2/3 pi times 4 cubed. Now 4 cubed, is 64. 64 times 2 is 128. So this ends up being 128 pi all over 3. And then we're dealing in centimeters cubed. And then my surface area, I'm going to use, since we're talking about a freestanding one, it's going to be 3 pi r squared. So 3 times pi times 4 squared. And I'm sorry, that looks like 41. It should be 4 squared. I'm going to rewrite that real quick. I hate when the computer does this. 4 squared. We know 4 squared is 16. 16 times 3 is 48. So 48 pi centimeters squared. All right, so those are our basic formulas. All right, and so my last problem is doing what I did in the last videos and everything, which is doing like combinations of figures. So here we have a silo, this time without the cone on top, but a hemisphere on top. So what you got to realize here is that the radius is still the same as it is in the circle on the bottom. It's just, it's up here now. Now, they want surface area and volume. I'm going to start with volume because volume is going to be the easier one to deal with because I have the volume of a cylinder plus the volume of the hemisphere. So that one's going to be the easy one to follow. So volume of the cylinder, if remember, is pi times the radius squared. So that's 6 squared times the height, which is 10. And so we end up with 360. And of course, it doesn't like me. 360 pi. And the volume of the hemisphere, I'll put a little sub h there, is 2/3 pi times 6 cubed. Now 6 cubed is 216. And then we're going to divide, and we're going to multiply that by 2, which gives us 432, and divide that by 3, and so that ends up being 144. So just plugging those numbers into the calculator that'll help you out here. So I get 144 pi plus 360 pi, and so that's going to leave me with 504 pi. And we're going to be like this today. And we're dealing in feet, so feet cubed. I really do apologize for the pen. It's not, it just doesn't like me some days. Feet. Let's see if we can get this word right. Cubed. All right. Now let's do surface area over here. I'm going to do it to the right. Now, I'm going to start with the surface area of, oh my gosh, really? We're going to do this. Sorry. You hear me commenting all the time on this. All right. So let's start with the surface area of the cylinder. Because I started with the volume of the cylinder. Now, normally, surface area of the cylinder would be 2 pi r squared plus 2 pi r h. But that's if it was a freestanding cylinder. But we notice that, one circle of the cylinder down here is exposed. And I don't know why it won't let me just do this. There we go. A little bit more shading in. Just doesn't want to follow. It's being picky tonight. We see that part is exposed. So that's one, but we do not have the other circle, which is up here, where the base of the hemisphere, it's covering it. So it's not actually on the surface. It's inside. So instead of being 2 pi r squared, I'm going to just kind of scratch through this too. It's only 1 pi r squared. So my actual volume would be pi times 6 squared plus 2 pi 6 times the height, which is 10. And so we get 36 pi plus 120 pi. That's 10 times 6 times 2 is 120. So my total surface area here is 156 pi. That's for the cylinder on the bottom. Now we still have to do the hemisphere. Now, same process with this one is normally this would be 3 pi r squared, but you'll notice that bottom pi r squared, that bottom circle is not exposed. So really we're only doing the dome again. And if you remember from the last slide, I told you guys that the dome is basically half a sphere. So that's only going to be 2 pi r squared. So in this case, 2 pi times 6 squared. So 6 squared is 36 times 2 is 72. So 72 pi. And then all we're going to do is we're going to take these two and we're going to add them up. And so my total surface area is 156 plus 72, which ends up being 228. 2, 2, 8. We're talking pi, so pi, and we're in feet squared. Seriously? Oh my gosh, that's I'm just gonna laugh at that one because that's ridiculous that line did that. Oh my gosh, I can't even race properly. This is gonna be this fun. All right, I'm glad this is the last thing. So, all right, so 228. Let's see if we can write it around right. 200, and of course it's gonna act up like that. 228 pi. See if I can box it in this time. All right, this time it follows me. All right, so there it is. Again, if you have any questions, just email me, and I will see you guys later.